Hello, welcome to this video showcasing my group, Robotics, submission for the robotics final. Our robot works in two phases. First, it explores the world to build a map, then it accepts input locations to move to. The first phase of exploration is done completely autonomously, so no predefined route and no RQT human-controlled teleoperation anything. Obviously, doing this autonomously requires hundreds of paths being planned and small movements being made, so the process is quite long, roughly 40 minutes. For that reason, we have sped up this portion of the video. While that plays in the background, allow me to briefly explain how the autonomous exploration works. A free point in the map is sampled, then the radius around that sample is checked. If this radius contains more than 30% unknown points, ignoring obstacles obviously, then this point is considered to be on the border of an unexplored region, and the robot will attempt to move there. On screen you can see an image of this in action. Those green circles are from different samples, and you can see one very close to the unexplored region. That's where the robot will try to go. At first the points are sampled in a small region around the robot, but if no good samples are found, i.e. the robot can't find any unexplored regions near it, then we'll start sampling from the whole map. This is done to prevent the robot from moving back and forth whilst exploring, making the exploration more natural. Once a point to explore has been determined, the robot must plan a path to that point. An interpolated A-star algorithm is used. This works by running normal A-star, which works on a cell-by-cell basis in the grid used to represent the map. The path returned is then interpolated, which essentially just means the robot tries to skip a bunch of points in the path. It does this to try to take fewer steps and thereby make the movement faster. An example of a path and this interpolation is shown on screen. This interpolated A-star is great because it allows the robot to take really optimal paths. But it can be slow, so for points far away it will usually reach its maximum iterations, and then bidirectional RRT will be used to generate the path. An example of an RRT path is shown on screen. Once no more points to explore can be found, i.e. it reaches a maximum number of iterations without finding one, the map is considered explored and phase 2 can begin. The robot has finished exploring the world, and I will now show the fully built map in the RViz tool. Very nice indeed. Phase 2 has now begun, and it is rather straightforward. We have a node that reads in an input location, and then the robot travels to that spot. The footage of it moving is slightly sped up for the sake of brevity. As you saw, I entered the location 09 and the robot moved to 09. The final part of the assignment was the visualization aspect. The robot must be able to detect the green utility cart and output yes or no to the VITS detector topic, depending on whether it sees it or not. So I start up the visual scan node, and clearly the robot cannot see the utility cart, so when I echo the VITS detector topic, we see it is indeed publishing no. I will now tell the robot to move to the point 5-2.
Destruction leads to a very rough road, but it also breeds creation. An earthquake's out to a girl's guitar, that's just another good vibration.
I will add the utility card. The robot is able to see it, so when I echo the VITS detector topic, I see the robot is, in fact, publishing yes. Oh, okay, whoopsie. Physics engines, eh? Let's just try that again. And there we have it. That is our robot in all its glory. Thank you for watching.